Material master definition. A successful materials management strategy begins with how materials are defined. Whether you're planning a capital project or operating a facility for decades to come, material master definition is the starting point. It establishes the structure for everything that follows, from requirements gathering to procurement, logistics, warehousing, and maintenance. While material master planning is critical during CAPEX, its greatest impact is realized in operations. Running a facility for the next 40 years or more requires a deeper understanding of how digital transformation impacts data quality, accessibility, and decision-making. Concepts like connected data, application programming interfaces, APIs, AI, data warehouses, cloud computing, and real-time dashboards or end-to-end visibility solutions are now fundamental to enabling a modern materials management environment and should be part of everyday discussions. Getting started. The entry point to this workflow is material definition. This is the single most important step when an organization invests in optimizing materials management. However, it's easy to get overwhelmed at this stage because it demands alignment across technical specifications, standardization of data within fragmented systems, and coordination among multiple departments. If ownership is unclear or governance is not in place, the effort quickly produces duplication and inconsistency. These problems ripple through procurement, fabrication, construction, and maintenance, creating inefficiencies that grow larger as the asset lifecycle progresses. To avoid these pitfalls, organizations benefit from breaking the effort into well-defined phases or working with a partner who can guide them through both risks and opportunities. When considering material definition, start by evaluating your current systems and processes. Even if you're starting from scratch, there is a current method in place for managing your assets. Key questions to ask. What technologies are currently in place to manage your master data? Are there clear business processes in place for creating, updating, and maintaining your material master? What are the pain points in the current process? Data quality and governance. Once the material definition is underway, the focus should shift to data quality and governance. These topics don't need to be finalized at the start, but organizations should have a clear understanding of their importance and a plan for adoption. Establishing a strong data foundation includes defining taxonomies, data validation rules, and governance structures. With this foundation in place, organizations can develop frameworks to monitor and maintain the ongoing expansion of the dataset. These concepts will continue to be enhanced as organizational maturity increases, which will ultimately drive ongoing innovation. Key questions to ask. How is data quality and consistency handled today? What are the key components of data governance to my organization? How will my organization comply with data governance policies in the future? Taxonomy. Defining taxonomy, rules, descriptions, material types, categories, and physical characteristics, such as dimensions, weights, and center of gravities, is one of the more resource-intensive parts of material definition. This work requires cross-functional collaboration and strong business process ownership. Depending on the scope of the material master, you may need a dedicated team of subject matter experts, SMS, willing to engage and collaborate to consider the end-to-end requirements. Drawing from existing standards like CIFHOS, ISO 15926, or PIDX to meet your organizational requirements can provide a strong starting point. However, these standards will have to be continually challenged as business needs and technologies evolve. Key questions to ask. Is there a clearly defined and supported business process owner? What are the taxonomy rules and descriptions needed for material types and categories? How will physical characteristics be documented and maintained? Integration and interfaces. Integration is a very complex phase of material master development. It requires careful prioritization, and the development process does not always follow a linear path. This phase also has a considerable influence on the types of data required during material definition. Understanding data ownership usually at the attribute level, adds to the complexity and demands clarity on responsibilities. Along the value chain, different owners will take responsibility for populating their portion of the data, which will impact the overall trust of a given asset. It is essential at this stage to identify and define the key applications that will either maintain the material master or publish data throughout the evolution of the asset. During CapEx, integration frequently resides within the Master Data Management (MDM), engineering tools (ERP), electronic document management systems (EDMS), project management (PM) software, and construction planning tools. In operations, on the other hand, interfaces will include MDM, ERP, CMMS, PLM, EDMS, PM, and EAM technology. Plotting out a high-level integration architecture will help drive prioritization and define a strategic roadmap for the future. Key questions to ask. What are the key methods, standards, and system requirements for integration across the value chain? How is material master data structured and formatted across systems? How often does data need to be synchronized between interfacing systems? Roles and responsibilities. Clear roles and responsibilities foster accountability and high-quality data management. Additionally, demarcation of a well-defined data structure enables cross-discipline collaboration, proactive data management, and streamlined processes throughout the asset lifecycle. With this understanding, organizations can facilitate better data compliance within the organization and to industry standards. Potential results include faster and more strategic decision-making, reduction in errors due to outdated or inaccurate information, and cost savings through resource optimization. Key questions to ask. Who is authorized to create new material master records? What responsibilities do data owners hold for each data element? What mechanisms will ensure consistent data usage across departments? What training programs will be provided to ensure stakeholders understand their roles and responsibilities? Audit, reporting, and analytics. Having a clear process for auditing, reporting, and analyzing material master data creates an environment of transparency. Prioritized data, real-time access, defined matrices, and KP lay the groundwork for AI integration, which can create a continual feedback loop for continuous improvement. Key questions to ask. Where are all the sources of information and how will they be integrated? How will we verify the accuracy of the material master data? How will audit findings be reported and addressed? And who is responsible for resolving findings? What type of reporting/dashboard is expected, and who is the audience? Thinking about the future. When the foundational elements listed above work in concert, the result is not only improved operational consistency, but also measurable cost savings and performance benefits. Cost savings are typically realized across the following areas. Administrative efficiency. Up to 5 to 10% reduction in administrative costs due to streamlined processes and reduced errors. Project cost control. Potentially 5 to 15% reduction in project costs through accurate material data and efficient resource allocation. Compliance and risk management. Approximately 5 to 10% reduction in compliance-related costs by ensuring data accuracy and regulatory adherence. In addition to financial returns, the greatest intangible benefit is trust in the data. While this variable is difficult to quantify, it is essential for quick responses and confident decision-making. With these building blocks in place, organizations can begin to capture and structure material data that spans the entire life cycle. This process is ongoing and will continue to expand to optimize other opportunities within materials management. And as organizations continue to mature, a knowledgeable partner can help accelerate this process. With the right support, companies can avoid common pitfalls, optimize implementation, and build internal capacity more efficiently. Most organizations in the industrial engineering space start with piping or bulk commodities. On the other hand, most operational facilities will focus on assets or critical tags. Regardless of the entry point, applying these principles across the entire life cycle brings greater value than limiting efforts to a single phase. This is where ReVisionz adds structure and clarity to an otherwise complex and resource-intensive effort. We help organizations define, operationalize, and sustain material master strategies that align with real-world use cases and system demands to close the gap between project priorities and operational needs. Our team combines more than a century of collective experience in materials management across both engineering and operations. This mix of subject matter expertise and business consulting gives organizations a practical advantage, especially when they are just beginning the journey. By drawing on lessons learned from past projects, we provide the insight needed to avoid common pitfalls, accelerate adoption, and embed practices that deliver lasting performance. Continue to reimagine each of these key elements as you embark on the journey of material master definition. A well-integrated strategy enables organizations to transform materials management from a static task into a strategic capability that powers performance across the entire asset lifecycle. Stay informed as the ReVisionz series continues to explore connected, lifecycle-based materials management. Subscribe for updates or connect with us directly to discuss your priorities. You can also visit our website to see the full guide to digitizing materials management. About the contributors. Clayton Cooper is Associate Partner of Materials Management Solutions at ReVisionz, where he helps lead the development and delivery of data-centric materials management strategies for complex industrial projects. With over 30 years of experience in piping design, line class data, and materials management, Clayton has deep expertise in configuring smart materials environments for EPCs and enabling owner-operators to unlock long-term value through integrated lifecycle-based solutions. His work spans the full project lifecycle, and he supports clients in establishing a single source of truth for materials data. Known for his ability to translate operational challenges into clear, actionable strategies, Clayton combines a highly technical approach with a people-focused mindset to drive transformation. Gill is Associate Partner of Materials Management and Digital Enablement Solutions at ReVisionz. He helps clients in asset-intensive industries strengthen project delivery and improve operational performance through data-centric materials management and digital strategy. With over 30 years of industry experience, Chuck has held leadership roles across both owner-operator and EPC organizations, giving him a well-rounded understanding of the challenges involved in executing large capital projects. His career has focused on optimizing materials management systems, navigating the full asset lifecycle, and resolving the disconnects that often emerge between project teams and operations. Known for his ability to moderate across functions and align competing priorities, Chuck has successfully led initiatives that establish governance, streamline workflows, and enable technology adoption.